All right, we're diving deep into an idea that is frankly a bit of a mind bender. It's based on the book The Rendered Cosmos, and it explores a concept that's jumped straight out of science fiction and into some pretty serious conversations among physicists and philosophers.
And it really all boils down to this one huge question. What if everything around you, the chair you're sitting on, the air you're breathing, your own thoughts, what if none of it is fundamentally real in the way we think it is? What if it's all just rendered?
So let's really get into this. The whole simulation hypothesis isn't just a fun what-if anymore. No, this is a serious idea that some very smart people are using to try and explain some of the absolute deepest, weirdest mysteries about our universe. Back in 2003, a philosopher named Nick Bostrom really kicked this idea into high gear with a surprisingly simple and powerful argument. Basically, he says one of three things has to be true. The first two are kind of downers. Either civilizations like ours destroy themselves before they get powerful enough to run simulations, or they just lose interest. But if you think any civilization anywhere ever gets to that point, then they'd probably run billions of these so-called ancestor simulations. And if that's true, well, simple statistics suggest it's way more likely we're one of the simulated minds than one of the real ones. Okay, so if we are living inside a giant computer program, could we actually find the evidence? Could we find the glitches in the matrix? Well, the argument is that the clues are hiding in plain sight, baked right into the laws of physics. It's time to go looking for the source code of our reality. Our first big clue comes from the absolutely bizarre world of quantum physics. See, scientists found out that our reality isn't smooth and continuous like a flowing river. Nope. When you get down to the tiniest possible level, we're talking the Planck scale, everything from space to energy exists in these little, indivisible packets. You can't have half a packet. It's all or not.
And the perfect way to picture this is to think about the pixels on a screen. Your screen has a maximum resolution, right? It's made of a grid of tiny dots. Well, a quantized universe is kind of the same thing. It suggests our reality has a fundamental resolution limit. And that is exactly what you'd expect to find in a system that's being computed, a system with finite resources.
Now, this brings us to one of the most famously weird things about our universe. A particle, like an electron. When you're not looking at it, it doesn't really have a single, definite location. It's more like a cloud of possibilities. But the very instant you measure it, bam, that cloud collapses and the particle is suddenly right there in one specific spot. So why would reality do that? It seems so inefficient. Well, in the world of computing, it's the most efficient way to do things. It's called on-demand rendering. A video game doesn't waste its processing power rendering the entire world all the time. It only renders the details that the player is actually looking at. The parallel here is, well, it's pretty startling.
In this idea of built-in limitations, it doesn't just stop at the quantum level. Our universe seems to have these strange, hard-coded rules that feel less like organic laws of nature and more like system parameters somebody programmed in.
The most famous limit of them all is, of course, the speed of light. It's the ultimate cosmic speed limit, an absolute, unbreakable rule for anything with mass. You just can't go any faster. End of story. And that just begs the question, why? In a purely physical reality, why should there be a hard cap on speed? Why can't you just keep pushing something to go faster and faster forever? The fact that there's a limit at all suggests something is regulating the system. The book gives this fantastic analogy. Think about a graphics card in a computer rendering a car in a racing game. As the car goes faster and faster, the GPU has to work harder and harder to update its position and render it smoothly. Eventually, you hit the processor's limit, and what happens? The game starts to stutter, lag, or just freeze. The system can't keep up. And this leads to an amazing idea. What if the speed of light isn't a physical barrier, but a processing limit for the universe itself? Maybe the reason it takes infinite energy to reach light speed is because the computational cost for the simulation to render you moving that fast becomes too much for the system to handle. It's like the universe's CPU is hitting 100%. Okay, I know, this is all really compelling stuff, but you're probably thinking, come on, there have to be some massive holes in this theory. And you're right to be skeptical. The biggest objection is that simulating a whole universe would just be impossible. So let's tackle that doubt head-on. This is often called the weather argument. Look, even with our most powerful supercomputers, we can barely predict the weather a week out because it's so incredibly complex. So how could anyone or anything possibly have enough computing power to simulate an entire universe, down to every last quark? But here's the clever answer.
It wouldn't have to. You see, any smart simulation would use shortcuts. You don't need to render every single atom on a distant star. You just need to create the illusion of a complete universe. By using efficiency tricks, rendering things with less detail when they're far away, only calculating things when someone's looking, and using approximations for huge complex systems.
And if you're still not sold on the impossible complexity argument, just look at us. In about 50 years, we've gone from Pong, literally 2 rectangles and a dot, to creating photorealistic, fully interactive worlds in things like Unreal Engine 5. Now imagine that rate of progress continuing for another 1,000 years, or 1,000,000. What seems impossible to us now might just be a weekend project for a far more advanced civilization.
So, let's just go there. Let's imagine for a second that this is all true. We are in a simulation. What does that actually mean for us? For our lives, for meaning, for everything?
Well, here's a surprising twist from philosophers like David Chalmers. A simulated reality isn't necessarily a fake one. Think about it. The joy you feel, the pain, the love, those experiences are absolutely real to you. Your reality might just be built on a different substrate, information instead of matter, but the experiences themselves are completely genuine. What happens to you still matters. Of course, this all leads to the biggest question of them all. Why? Why would anyone create a simulation this vast? Maybe our far distant descendants are running it to see how they came to be. Maybe it's a giant science experiment to see what kind of cool new consciousness evolves. Or, and this one's a little more chilling, maybe it's just some ancient program that was switched on and then forgotten, left to run for eons. In the end, what's so fascinating about the simulation hypothesis is that it offers this weirdly consistent framework. It takes some of the strangest, most counterintuitive parts of our reality, the pixelation of space-time, the speed limit of light, and suggests they're not bugs, they're features of the system we're running on. Which leaves us with one last thing to chew on. If this reality is a perfect simulation, so flawless that you could never, ever prove it or find a way out, if you truly can't tell the difference between this world and base reality, does it actually matter?